Okay, okay. We're not doing too bad. We're not doing too bad. I am 4 minutes earlier than I'm supposed to be on. What did they say? No results keep going, bad results keep going, good results keep going, no matter what, keep going. Do not be the best, as I tell you. Be the best at not giving up. All right? You do not have to be the best. Just be the best at not giving up. Right? That's it. That's it. You know, we have to improvise. We have to improvise. We have to find different ways to. Oh, that's why I was wondering what was going on. All right, I realize what's going on. I realize what's up. Yeah, sorry. I love doing faceless content because there's a whole lot that can be going on right now. And yeah, wardrobe changes, you know, things like that, so it make life kind. Of convenient. Um, yeah, like I have a, I wouldn't say a hamstring injury, but definitely, yeah, like it's a bit sore. It's a bit sore from me standing up in a very strange, you know, like leaning on one side kind of thing. If there's one thing that I appreciate about track and field when I did it, it made me very sensitive to the muscles that I have. So whether it be your thigh, the hamstring, the calf, yep. Anytime there's an issue, I I pick up on it real quick. I pick up on it real quick. So yeah, let me apologize for the awkward silence, right? Yeah. So I am doing a bit of a wardrobe change, right? Doing a wardrobe change. Oh man. You ever do something to yourself and you say, well, I guess. Yeah, sometimes you do something and you ask yourself, like for example, like you might have a shirt and you don't wear it as often, and you're like, why I don't wear that shirt? Because it's itchy, you know? Things like that. You look at it and say, I don't need to wash this, I don't need to iron this because I'm never wearing it. It's one of them ones. It's one of those stories, right? So yes, ladies and gentlemen, I did 2 TikTok lives today, Monday, 3rd of March. Yeah, that's never fun. Um, yeah, so I'll just play the video and see how much of it I need to skip past. We'll see. All right, so all right, so sometimes you have metric, sometimes you have imperial, right? So let's say we have. Let me just write down some examples of it. So let's say we have this. 1 yard is this, and 1 yard is this, and then yeah, for this one, 90, and then let me see another one now. I don't remember the imperial them out of my head. Man, I remember them. I just write down what the conversion rate is, and that's pretty much all you need, right? You just need. So okay, let me just write down a few of them. So I have that. That's 2.5 centimeters, right? And then and what else am I going to write? Yeah, alright, fine. Let's write that. So let's write the, yeah, whatever. 1 mile is something like that. Well, okay, so alright, before I kind of just randomly picked up a question for the arithmetic sequence, but this time I was doing a little, just converting, smaller units to larger units and, that sort of thing. But also, seeing that these are imperial, which is obviously not the typical thing like when you have metric, because with metric you're literally just multiplying by powers of 10 or dividing by powers of 10, so the metric is a little bit easier to do. So let's say they gave us let's say they wanted us to find, like, convert 108 inches to say to yards, basically, right? Now, a lot of people like to do this thing where them tell you if it's larger to smaller, you divide and multiply and this and that. I don't like mix people up when it comes to that, right? I don't like mixing people up when it comes to that. So what I tend to do is I say, okay, we just have to focus on the units them asked with us. So therefore, we have inches and we have yards, right? So obviously we have to map that to whatever we see. So we have to look for anything that have inches and yards. So this is inches and centimeters, so we can't use that, right? This have yards but no inches, yards no inches. But this right here have the yards and inches, so we'll go use that, right? Now, sometimes they like to write it like this. Sometimes them flip it around. Sometimes they must say, sometimes they like to do that, right? No, oh, look at that. You actually work it out already. Okay, nice. Yeah. So yeah, sometimes they actually, them flip it around, right? Them flip this around. I like to keep the one on the left as opposed to on the right, yeah? I like keeping it on the left. So a lot of times you look on the exam paper and they kind of flip it around, but me, I like having the number 1 on the left and this on the right. So I will just write this first. So I write this. Oops. That just looks like an N. Alright, so I have that. And then now what I do for the fun of it. Oh, hold on here. I did something crazy a while ago. Why did I write inches on both sides? Yeah, sorry about that. Okay, so yeah, so we want the 108. So what I do sometimes, I do this. I just write them on both sides anyway, and then obviously you just look at which one actually looks, which one of them actually look correct, right? So
birds of a feather flock together. They have the same. So once the units are the same, then that's where it should be, right? So it really should be over there and not over here, right? So when I erase that now, I just put a box in place of that. Now there's a shortcut to all of this madness, because in reality what is happening is that this answer is multiplying by that, and the result of that is equal to this. But to make your life easy, what is really happening is the box is equal to this number divided by that number up there. So you're just going to divide your 108 by your 36. So whatever this answer is, you just put it in here. Or you can write it separately if you want, but yeah. And as you would, yeah. So you could now mind you, the question is how you do that if you never have a calculator. Well, I mean, we can always do that, We never have a calculator, we can always do that. So well, 36 plus 36, we get this, and add this plus that, we get this, right? Can see that now? Oh, yeah, we can see that now. Alright, so yeah, so $1 can't buy nothing, right? $10 can't buy nothing, and 108 bigger than this equal to that, so therefore yeah. So yeah, so in the event now, so I forgot, there was a trick that I forgot to tell you. So let me tell you how I remember when I must divide and when I must multiply. So the trick that I always say is, when the box is on the left, that is when we divide. Yeah? So when the box is on the left, that's when we divide. Right? So that's the cue that I use. So the cue that I use is, when the box is on the left, we divide. And it don't matter, because even if you do the algebra way, you still go end up dividing anyway. Because let's say you end up with 36 times box, you end up with 36 box equal 108, you still go have to divide both of them by the 36, so you're going to end up with that anyway. Right? So I feel like when I say box on the right multiply, box on the left you divide, I think it work out. It work out. So okay. So let me do something a little bit on the other side of it now. So let us say I said, let's convert let's say 4.5 yards to inches. So that means I'm have to go get rid of a portion of this, maybe not this part. So you still gonna need the main conversion rate, right? And funny, the way how we do this, we can even use this for foreign exchange as well. Like we can, let's say we want to convert like Jamaican dollars to US and whatever, we can do it just like this too, right? So this time we have the yards going to inches, right? So again, we can test the waters, right? Just put it on put it on both sides and see which one of them look right. Obviously the one where we, yeah, the one that match, yeah, birds of a feather, right? So naturally the box gonna end up on the right this time, yeah. So we do this, yeah. So before the box is on the left, now, oh sorry about that, yeah. So now our box is on, yeah. So now we're going to have to take this and multiply it by that, yeah. And oh, okay, so here are two things you can do when you have whether you have decimals or whether you have the fractions or whatever. Now you can do this two ways, right? You have 36 times 4.5. Literally, if you wanted, multiply this by 45 and then divide it by 10, because 45 divided by 10 is the same as 4.5. So you can ignore this, multiply it as you would, and then just jump back by 1 decimal point and there's your answer. That's one way of doing it. Another way of doing it is, if we recognize that 4.5 is the same as, well, 0.5 is 5 over 10. So you're literally saying 4 and 5 over 10. And if you reduce that, you would get 4 and 1 over 2. Right? Then now, if you want to convert this, right, 2 times 4, 8 plus 1, you get 9 over 2, right? So you could just, instead of using 4.5, you can use 9 over 2 and multiply it by 36, right? So that is an option too. And I promise that you will get the same answer whether or not you want to use your decimals or you want to use your fraction, yeah? So let's pretend that's not there. Yeah, so 6 5s, we have a little 30 this, so 15 plus 3, so we have 18 when we add 15 plus 3. 36 plus 36, 72, 72 plus 72 is 144, so this has to be 144, right? So 12 right there, 1, 4 plus 2, yeah. So therefore, if we jump back one time, yeah, so our answer would be 162, right? So we would have that. So our answer is 162. And the good thing with these type of questions is that you only have two choices. You're either going to multiply or you're going to divide, right? And the box will tell you what you need to do. That's what I like about this. If the box is over here and the one is on the left, then once the box is on the right, you go multiply. If the box is on the left, you divide. Because let us say we wanted to do it in reverse. So I could always switch this around and say, fine, let us go back in reverse then. Let us say we are looking for 162 inches to convert to yards. Now the good thing with this is that, again, it don't matter what unit we get, as long as we have the rate, as long as we have the initial rate, we can always find it, right? So get rid of all of this. Let's get rid of all of that. and see what happens when we flip this around. So that right there, that right there. 1 yard is this. Right, so again, so we're going right, we're going inches to yards now. So right, my equal sign there. I can put them on both sides just to see if it makes sense, so that I know where it needs to be. So if you're writing it in pencil, you can rub it out from over here, because they're not, the units are not the same over there, so you can do that. And then when you rub out this, you just replace it with a box. Right? So you rub out that, replace that with a, yeah, replace that with a box. And then of course, the trick is, the box is now on the left. Right? So if the box is on the left, we are going to, let me see where I can write it. Seriously? Sure. Yeah. Oh, that light there kill me. Right? Let me see. Yeah. Something like that. Yeah. Alright. Let me see if I can move the light somewhere else, so that it's not, you know. I don't know. Okay. Alright, that's, I don't know. I tried. I tried to make that a little better. So yeah, so now when you have this, all you're going to do is put a line right here, and that number, that any number that you see above, you just put it right there. That's what this is. The box will always be equal to this divided by that. So just put this number over that one. And yeah. So this will save you from guessing, really. You don't have to guess. So if the box up on the left, we're dividing, box up on the right, we're multiplying. And argument done. Alright? Argument done right there. So we will put the 36 here, 162 here. I create multiples of 36, right? So I will have 72, then 108, 144, 180, 216, 252, 288. Let me see what else. 1, 2, 3, 4, 5, 6, 7, 8. And then 324, then 360. Yeah. So let's see. $1 can't buy nothing. $16 can't buy nothing. So the 162 now is bigger than 1, 2, 3, 4. Now, okay, there's a little bit more though. So we can put a point right here and put a 0 behind it, right? So if I do this, right, the number 4 go up here, and let me put a point right here. Yeah, alright, move that. Kind of know what I was saying here already. Yeah. So I have to find out what I add to 144 to get 162. So if I add 16 to this, I get 160. So if I add 2 more, I get 18. So there we go. Yeah? So 144 plus 18 will give me this number. So I'll take that 18 and put in front of that 0 right here. So let me put that. Yeah. Yeah. So then now 180 is right here, don't it? Let me see if I can tick them so everybody can see. So we have 1, 2, 3, 4, 5. Right. So then there we go. We'll put the 5 here. Yeah. So if we don't have a calculator, we can still get the answer, yeah? So therefore this is going to be 4.5 yards, right? Yeah. So it don't matter what you get, whether it's imperial, whether it's metric. Once you have the box on the left and the box on the right, it shouldn't be. I mean, obviously there are going to be times when you just have to, I guess, be a little sensitive to the tricks you can use with your decimals and the fractions and that sort of thing, so that way you know what's better to use. Is it better to use the decimal or is it better to use a fraction? Sometimes, yeah, so sometimes some numbers will make that a little bit easier, right? So like when, let's say when the numbers are even and you have like a 0.5 or a 0.25, certain things you can guess, right? Because 4.25 is the same as 4 and 1 over 4. So if you add 4 and 1 over 4, you could literally say, okay, 17 over 4 multiplied by 36, and then, yeah, your life kind of nice from there. Yeah. So,
Wow, we didn't do too bad, right? We didn't do too bad. So the timestamp here is exactly 38 minutes 42 seconds. So let's use that as a little marker as to where we left off with this one. Let me look at the the other live that I did today. Where's the other one now? Uh-huh. No, man. Hold on. Oh, okay. Yeah, I'm looking at it. So one is called CD94. CD94, and the other one is 127.46. Okay, all right. Let's. Yeah, this one was for like an hour and a minute. Wow. Yeah. All right. So we spoke about finding LCM and all of that. Yeah, let's see what we're doing here.
the 3 by 3, this is 2 times 12, but the 12 is really, what, 4 times 3? So you have, so let's say you do that. But then the 4 is 2 times 2, so we're not for waste of time with that. So we know, right? And then 32 is 4 times what? 8. And 8 is what? 3 of the 2's, and you multiply them. Yeah? So, what would we do with all of this? Well, we have a room, we have another room, and then we have a house. So the question is, if you wear size 5 would you need this or this? No, you're not going to wear a size 1 or a size 3. Right? Or if you have a 1 terabyte versus having a 5, you might as well keep the 5. Right? This is in here already. This is already in here. So you don't need this if you have this already. So get rid of that. Yeah? Then you will have this 3x3 and the 3 alone. This is already up here. So just like that, you have everything what you need. All of this is 32. This 3x3 is 9. So you multiply 32 by 9. Right? 32. Alright, 288. Yeah. So your denominator, your new denominator is going to be 288. Right? So if we were to write it out, you would write out the 5 2s and the 2 3s, and when you multiply everything, you end up with that. Yeah. So if you can find the let me not say that again. If you can find the LCM of any 3 numbers, then when you get them as fractions, you know what to do. Right? So therefore, the LCM is what would go here. You have 288 here, 288 here, 288 here. Yeah? So if you take this out, this part is the 18, right? So if that part is 18, then the part that's left is 16. So let's multiply 16 by 18 just to be on the safe side. Yeah. So 128 plus 160 is 288. Yeah. So therefore, this 18 must be multiplied by 16. Yeah? Because if you were to blot this out, then what you have left is 2 by 2 by 2 by 2. That's 16. That 16 is multiplied by 18 to give you this. Now what about 24? 24 is what? This right here. Right? So that means what's left is the 12. 2 by 2 by 3. Alright, let's multiply 24 by 12 and see what we get. So we have 48 and 240. Yeah. Oh. Yeah, there we go. So yeah, 240 plus the 48. Give it 288. Therefore, 24 times 12. Yeah. 24 times 12. So that means we have to multiply this by 12 and that by 12. And we already had our 32. Right? This part here. That is our 32. So that what is left is 9. So I've multiplied this and that by 9. Now only God knows why I put a minus sign right here. So this we should have put over here, so because Anyway, it's fine. It's fine. Let's just put a plus just to make our life nice. So anyway, 1 times the 16, that go up there. 12 times 5, that go up there. This is, yeah. There we go. How we that? Yeah, sometimes alright. I don't know if it's too bright now. Alright, let me minimize that. I want to see. Yeah, yeah, yeah. Hold on there. Well, no. Not the best we can do. Because it's either I'm gonna use the laptop screen or whatever. I don't know. May I try, man? May I try? At some point, I'm going to have to use another light other than this. But for right now, yeah. You know. But then again, there was something that I had in mind, but I don't want to use one of the phones. But I'll figure it out. Okay. Yeah. So that was 1824 and that. So the challenge when you're doing this is if you can't find the LCM of the numbers, you can find the HCF of them as well. Right? That's the, so any group of numbers that them ask you to find the LCM of, you must be able to find the HCF of them as well. Right? So let's say you had 54, 72, 108, and let's say same thing over here. Yeah, the same numbers are going to go up. This is 27 plus 27, so 27 is 3 times 3 times 3, multiply that by 2. So we have that. This is 8 times 9, so you're going to have 3 2's with a double 3. And then what? This is 54 plus 54. So take all of this and put down here. And then drop another 2 in front of that. Yeah. And whatever you get over there, you get over here as well. Yeah. Yeah. So let's say on so let's say we had LCM over here and HCF over there. Or maybe let me see which one easier for do. Yeah. Let me do it like this. Yeah. No. We could try this again. Okay, alright. Fair enough. So circle all of your 2's. And obviously 2 by 2 by 2 bigger than this and that, don't. This already up here, so you don't need this. That already in here, so you don't need that. Now this and this are of the same size, so you don't need I mean, if you have one of them that's a 3x3, you just pick one of them. So you don't need the two of them. So let's just get rid of one of them then. Let's get rid of that one. And then this, between this and this now, you have to dash with this one. So let's do that. So therefore, the LCM of this is going to be, okay, this is not what I expected. I think I know what number I go see. This number is going to be 216. Yeah, because you have 3 2s and 3 3s. 2 times 3 is 6. 6 times 6 is 36. And 36 times 6 again is going to be 216. Yeah? So that's the LCM nonsense, yeah? So this is the smallest number that all of them, this number can be divided by the 54, by the 72, and the 108. Right? If you add 108 to itself, you get this. So 108 times 2 would give you that. 72 times 3 would give you this. And then what? With the 54, this would be 54 times 4. Yeah. Yeah. Now, over here, you just pick what they all have in common. You just circle what them all have in common. So, let me see. There's a 3x3 in all of them and a 2 in all of them. So, let's do this. You have a 2x2x3, a 2x3x3, and another one of these. So the real question is, do we need to go further than that? Well, we have 2 2s here, but we don't have a 2 up there. We have a 3 here and here, but we don't have an extra 3 there. So, yeah. So with that now, the HCF of this is 2x3x3. So this is going to be 2x3x3. And our answer for this is going to be, yeah. Yeah. So the number we can divide all of this by is 18. So we can divide 54 by 18, end up with 3. 72 by 18, we end up with 4. 108 by 18, end up with 6. Yeah. 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 So I guess it's good practice to get any set of numbers that you can find the LCM of, find the HCF of it as well. Sometimes you're not going to have an HCF depending on the numbers. Because if you have, let's say every number is prime. If every number is prime, there's no HCF at all. Right? Let's say you had 23, 29, and 31. There's no HCF to be found here. Because the prime number for this is 23, this is 29, this is 31. You can find the LCM, but definitely not the HCF. Them don't have nothing in common. Alright? So when it's all prime numbers, there is no HCF to be found. Alright? So we don't have to waste time with that. I mean, the only HCF is really one. It's really one. The HCF of all prime numbers is 1. Because you can multiply 1 by it and get the number. So, yeah. The HCF of all of those would be 1. Yeah. For the prime numbers, that is. So if it was only prime numbers you were looking at, then because they can't be broken down, you're going to need all of them. So therefore, you just multiply all of them together. Yeah? So if you find the LCM of all the numbers and all the numbers are prime, you have to multiply all of them. Yeah. You have a choice with that. We do not have a choice when it comes to that. Let me see. Can I pull this over a little bit? Okay. Yeah. Just a little bit. So yeah, the more of these we do, the easier it is. So let's say you even get 9, 12, and 15. Right? Let's see how that would go. We'd have a 3 by 3. Three by 3, 2 by 3. You see what I'm do a while ago? At 18 me I think about. I was thinking about 18. Yeah. So if we're finding the LCM for this, I mean the HCF for this is a no-brainer. The HCF is this. So the HCF of 9, 12, and 15 is going to be 3. So that done. So we don't have to guess that. Alright? So we don't have to guess that. So therefore, when it comes to the HCF is the easier thing to figure out. At least depending on the numbers that you get. Depends on the numbers you get. Alright, so let's do this again. 3 by 3, 2 by 2 by 3, 3 by 5, and we're looking for the LCM. So, fine. Have an idea. Let me circle the 3 by 5 and let me circle the 3. Now if I have a 3 by 5 and a 3, I'm going to work with the 3 by 5. Alright, so get rid of that. Now there is a 3 in the 3 by 5 that have something in common with the 3 by 3. So if I'm circling just this, hold on, no. Yeah. So this 3 out of this 3 by 5 is already up here, so we get rid of that. And then we just have a 2 by 2. Yeah, I like that. Have me away, but yeah, let's see. Can I move this up? Let me move this up and let me see something. Ah, there we go. Yeah, that look a little better. Ha! That's giving me an idea. It's giving me an idea. Look at that. Ha! I just get an idea a while ago. I just get an idea. Yeah. Alright. It's fine. I just figured out a solution to one of my problems then. Alright. So now that we have that, we just write them down. Alright? So let me write it down. Really? Alright. So we're going to write so that's what it gonna be. I don't know. Let me see. Let me see. Yeah. Really? Hold on there. We'll put it on the other side. Yeah. That could have worked. That could have worked. Alright. Give me 1 second while I set this up properly. 1 second while I do that. Let me see. That could have worked. Alright. So the middle part right here, so. The middle part. That is what? 3 times 3, 9. 9 times 2, 18. Now this part here, the 2 by 5 is 10. So therefore 18 times 10, our LCM for this is going to be 18 times 10. 18 times 10 is going to be 180. Yeah. Yeah. This is in my estimation the most reliable way to get your LCM without running into much difficulty, right? Because the largest amount of 2s is 2 by 2, the largest amount of 3s is 3 by 3, and then the largest amount of 5s is just 5 by itself, right? So if we practice doing this, and look at how funny it is. 9, 12, and 15, and the LCM is 180. I wasn't expecting the number to be that big. You know, I wasn't expecting that. You know, wasn't expecting that. The HCF is much easier to find. The only time the HCF is difficult is when the numbers are large, right? So let me try and find an example of, like, all right, let's try 960. 960? Lie. Alright. So we had a good look at this. So we're gonna get rid of it now, right? We had a good look at it. So let me move on to the next thing, right? So let us say we're finding the HCF of 96. What other number there? 160 and 224. And this time of the HCF we'll look for. Now something like this would be helpful if we're dealing with like a funny story. Even when you're factorizing, you need this. Yeah? Like when you get to the higher level mathematics, even then you still need to know what the HCF is. Right? So okay, 96 is 8 times 12. And then this, if we break it down, this is what? This is 2 times 2 times 2. And then that is 2 times 2 times 3. So therefore, we can put 5 2's up here and the 1 3, and then of course multiply all of this. Yeah? So we have that. So we're done with that up here. So let us look for 16 times 10. Now this is going to be, well, what is now? This is 4 2's and this is a 2 by 5. So that means that we're going to have 5 2's and a 5. So we'll have alright. That's what that is. Okay, the 224 is a little tricky, but because it ends with 4, 2, 6 or 8, we must can divide it by either 2 or 4 at some point. So let's see. If we divide this by 4, alright, 8, 12, 16, 20, 24, 28, 32. Alright, so can't buy nothing with $2. Go to 22, it's bigger than 1, 2, 3, 4, 5. Yeah, I have it down a little bit too low. Alright, so we have 5 up here. And what we add to 20 get 22 is 2. That 2 go right there. 24 is right here. So 1, 2, 3, 4, 5, 6. Alright. Now that's interesting. So therefore, you have 4 times 56. So make we look on this now. We're sure about 4 and we're sure about 56. Sure about that. So make we do this. 4. This is 8 times 7. So that means that we're going to have that. We're going to have that. So 2 times 2 and 2 times 2 times 2 times 7. So we have 5 2's and a 7. Yeah. Yeah. So now they make it pretty obvious what the HCF of this is going to be, right? So what we're going to do now, this is in line 1, this is in line 2, this is in line 3. Therefore the HCF is really 2 to the 5 Oh, really? Why? Yeah. I don't know what just happened a while ago. Anyway, yeah. So yeah, 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2. Yeah. The LCM of this, would have be this number times 3 by 5 by 7. That's what it would have be. So if you are looking for the LCM for this, seeing that this and that are the same size, you only need one of these, right? So you know cross out this, whoops, cut that, man. Yeah, so you cross out this and that, right? Or you basically you could have circled a whole of that, and then since this and that would have become, and you just cross them out and then pick up the 5 and 7, and that's it. So the LCM of these three would be 7 times 5 times 3 times all of that. What that would have been? 21 times 5 is 105. So the LCM would be 32 times 105. So the LCM would have been something like, oh, that would have gone on. You could have said 21 times the 16 and then multiply it by 10. So 21 by 16 alright, 336. So that would be 3,360 then. So yeah, something like that. Yeah, 7 times 3, 21. 21 times 16 would that be 336 multiplied by the 10. Yeah. Now I do have an LCM calculator, but I probably have to use my tablet and get it done. So let's see if I can find it. Really? Yeah, sorry about that. Sometimes my tablet decides because, you know, sometime it say, well, you've not used me in so long, I'm going to operate very slowly. Alright, may I look for my browser? Google Chrome, where are you? Come on now, come on now, come on now. Come on. Yeah, I apologize for the awkward silence, yeah? Calculator soup. Come on. Come on. For the love of God, what is that? That's not even a letter. What is that? Listen to me now, man. I'm gonna press go. Going to press go. What? You know what? No. You know what? I'm gonna just write LCM calculator and call it a day. Because LCM calculator. Eh? No. Anyway. So them change from .net to .com. Alright, whatever. Alright, 160, 224. Alright? Not sure if you can see it. Ah, look at that. That don't look too bad. That don't look too bad, you know. Yeah. So 96, 160, 224. Let's see what we get. Ladies and gentlemen, let's see if it look good. I don't know if you can see it. I don't know. I'm trying to see it. What? Let me see. Yeah, man. See there? Yeah. So we never too bad. So we actually got it. We actually did get this. Yeah. So it's good practice when you can do the HCF and the LCM, because if you can do it, then when you get the more complicated thing, them, you know, the smaller fractions, the smaller this and that, it's easy to do. Suppose you did supposed to reduce 96 over 160 to its lowest terms, right? If you wanted to do that, then imagine this for a minute then. Imagine, say, you have 96 over 160. What would actually happen? You would have had over right? So you imagine this. The HCF, we find it already. The HCF for 32. So the HCF for this and this is this. You draw your line through that. Right? Anytime you're reducing fractions, you're finding the HCF of the numerator and the denominator. Once you find the HCF, you cross it out. 96 over 160 is 3 over 5. Yeah? That's really what that is. Yeah. So, you can use this to find the HCF, but you can also use it to reduce fractions as well. Yeah? And if you can find the HCF, you can also find the LCM. Yeah? But it is weird because the numbers, every set of numbers have different relationships with each other. So you just have to experiment with them and try the different questions and see how often you get it right whenever they mix up the number them. Right? Because there's a time when two numbers are multiples of each other, but one number is the odd one out. They always tend to do something to that effect. So for example, you might have 8. You might have 8, 18, and 27. Now if you have 18 and 27, 18 and 27 are related because they're divisible by 3. But 8 isn't divisible by 3. You know? So let's even use that small example there. Let me use 8, 18, and 27. Right? Whether we want to find LCM or HCF. So let's use 8, 18, 27. Right? So we have We have a triple 2 up here. See? So, mind you, finding the HCF of this would be next to impossible. At least the HCF would be 1. Yeah? Because you have a 2 up here and here, but not down here. You have a 3 and a 3 here, but not up here. So you wouldn't be able to find a HCF of these 3. Right? So there are times when the only HCF of the numbers is really 1. So the HCF of 8, 18, and 27 is just 1. That's it. Them not have nothing else in common other than the number 1. Right? So therefore, since you can't find an HCF for that, you have to go find the, yeah. So what do we have here? So we have a 2 by 2 and a 2. You have a 3 terabyte and a 1 terabyte. You're going to buy the 3 terabyte. Yeah. Then you have a 3 terabyte here and a 2 terabyte. This is already down here, so yeah. And funny, multiple of 3, multiple of 3, multiple of 2. This is the odd one out. Mind you, these are both multiples of 2, but this is not a multiple of 2. Right? So this is a multiple of 3, this is a multiple of 2, multiple of 2. So this is the odd one out in that part. But this is the odd one out because this is the multiple of 2 while these are multiples of 3. Right? So they like to do that sort of thing sometime. Yeah? So therefore, our LCM is going to be, from what I recollect, it might be 216. This is the second time I get in this number. And I'm actually going to put it in the calculator soup and see what we get. Alright? So let us see. We'll put in the numbers 8, 18, and 27. 8, 18, and 27. So let's see. Don't know if you can see that. Yeah. Right? So when you put in the, I don't know if you can see the 8, 18, and 27. I don't know. Yeah. Yeah, man. There we go. That's it. So, I like doing this because when you have a good understanding of this, then even when you're doing the more advanced topics like factorizing, like reducing fractions and them sort of something there, you can just pick up the numbers that related to each other really quick, right? You can look at 90 and 144 and see them related, right? Because 144 have at least a 3 in there, yeah. So whole heap of different things you can do when you know how to confidently find your LCM and your HCF. Yeah. You know what I should do? Let me tell you what I'm gonna do. I'm gonna treat this like a one class my day. So how about we write down some and say a homework that. Something like that. Why not? So if you can look here, if you can find the HCF, you can find the LCM. So find the HCF and LCM of all of these. So find the LCM and, yeah. So find the 2 of them. So find, yeah, of all of them number here. So we have 9, that it looked like a G a while ago. 9, 15, and 24, 12, 30, and 42. Alright, them say 54 and 126. 30, 45, and 75. See what else? Right there. Alright. 24, 40, and 60. No, 64. I don't know why I said 60 a while ago. 35, 50, and 65. And a couple more, you know. Couple more were a little more difficult than this. 60, 84, and 108. Why not? 112, 70, 112, and 154. And 154? Yeah. Oh. Alright, now I have to pull this over a little bit. Can I do that? Alright, yeah. We did do well. Why not? 144, 216, and 360. Okay. Alright, this one is whole heap. 81, 108, 189, and 270. I will eat this. As a matter of fact, that's the last one. I think we can make that be the last one. Or no. Okay, alright. 72, 108, 108. Boy, okay. You know what? I'm going to write them so. Alright. I know what I'm going to do. 72, 108, 180, 288. And then the other one now would be 81, 189. Sure, I didn't want to write them in order, but it's alright. And then this one is what? 270? Yeah. So therefore, yeah, this is one, this is another. Yeah. So let me see. So 1, 2, 3, 4, 5, 6, 7. Really? How does 7 look so? 7, 8, 9. This would be 10. I suppose that's 11. And let's see what else. Mm, all right. This one not so bad. 48, 80, and 112. Why not? So I put 12 over here, so even though that's kind of 48, 80, and 112. 48. See if that. Yeah. Yeah, man. That. This look like good practice now. Yeah. Yeah. No. No. Let's see. Let's just see how much of it everybody can see. Alright, yeah. Yeah, that we'll go on this. We'll go on. We'll go on. So the beauty about doing these is that, again, once you're dealing with the adding and subtracting of fractions, once you can find the LCM easy, when you get the fractions to do and you need to find common denominators, is a breeze after you can go through this. Breeze. Because you get accustomed to finding the prime factors of every number. Right? You can look on 64 and know how much this is supposed to be. Right? You can look at 40 and know what's supposed to be in a that. Yeah? All of the number them you can find anything you want about them. Right? Because you can look on this and say, alright, 72 plus 72, I will give you this number. Right? And you can say 72 times 3 will give you this number. So sometimes you can look at a smaller number and make up the bigger one then. This, I remember this from doing whole heap of questions about finding the radius and things like that. Yeah? So therefore, 77 plus 77 is 154. So therefore, you have 2 times 7 times 11. Yeah? So therefore, this have to be 2 times 7 times 11. Right? This look like when you add 56 plus 56. So therefore, you just multiply 2 by the 56, and 56 is already what? 8 by 7. So that this is the same as like 16 times 7. Yeah? So when you can find the prime factors of every number, this just gets easy for do. So maybe that is something that I can explore on another time. Just finding the prime factors of every number. Because I actually have a table for that. I have a table with like all. Even when I did teach me, used to make my student them write them off. Because sometimes it's good when you have them in your head. So like all this now, you said this is 2 by 5 by 5. This is 5 by 7. This is 5 by 13. Sometimes I just look on the numbers and I know what to expect. Yeah, so yeah, I'm gonna wrap up your sum. So find LCM and HCF of things like that. And when you can do this, anything else you get easy street. Easy street. So are we that now?
Okay, I don't know how long this thing was done, but I must apologize for not paying attention. Dear Lord. I mean, really? This is a 1 hour and 1 minute video. I don't even remember when this got done. Yeah, yeah, yeah. Okay. So anyhow, I guess thanks for helping me to stay consistent and yeah, yeah. I guess I'll find something else to play before. Let me not. Yeah, let me try and find something else. Something else. Maybe the end. How about the end to this? Oh, yeah, why not?
Whether it's metric, once you have the box on the left and the box on the right, it shouldn't be. I mean, obviously there are going to be times when um you just have to, I guess, be a little sensitive to the tricks you can use with your decimals and the fractions and that sort of thing, so that way you know what's better to use. Is it better to use the decimal or is it better to use a fraction? Sometimes, yeah, so sometimes some numbers will make that a little bit easier, right? So like when, let's say when the numbers are even and you have like a 0.5 or a 0.25, certain things you can guess, right? Because 4.25 is the same as 4 and 1 over 4. So if you add 4 and 1 over 4, you could literally say, okay, 17 over 4 multiplied by 36, and then, yeah, your life kind of nice from there. Yeah, yeah. So, and when is metric is a lot easier. Yeah, you don't have all of this to contend with. But there is one thing. A lot of times, the question that they like to do is the one about scaling, right? And they don't. So, for example, when they give you a scaling question, right? Typically, they will write something like, let's say 1, and let's say them say 375,000, right? That's what they will do. Now, it is up to us now to change this into what it really is, right? This is actually saying that this is 1 centimeters on a piece of paper on the left, and on the right, the actual distance is this same number again in centimeters. So therefore, the unit for both the right and the left is in centimeters. Now, it's our job from here now to convert this to kilometers so that we know how many kilometers 1 centimeter actually represent, right? Now, here's the trick to that. The trick to that is they're assuming that we know how many kilometers give us how many centimeters. Oh, hold on here. The light kind of. Let me see if I can make it a little bit. Let me see if that makes sense. Yeah, alright. So, let's say you have 1,000 meters. Yeah? That is fine. But what that means is you really have 1,000 times 1 meter, right? That's really what you have. Now, if you want the centimeters, then obviously you have to say 1 meter is 100 centimeters. So you will literally, in the next line, write. So you literally yeah. So now it is 1,000 times 100 centimeters, and therefore you're just going to add 2 more zeros to that, And now, every time you think about 1 kilometer, it is going to be equal to 100,000 centimeters. Yeah? So, I don't know, I could have probably write that better though. Let me see. Write that little better. Yeah. Yeah? So yeah, so you don't necessarily have to do this. This is just my way of making that part of it make sense, right? If you remember, you can just literally add 2 more zeros to the 1,000, so you get 100,000 centimeters. You can do that as well, right? But this is just showing that every single time 1 kilometer gives us 100,000 centimeters, right? So that part we know. And funny story, these questions appear on City and Guilds and CSEC. I guess stage 3 for the City and Guilds, and you know, you'll see this on a CSEC paper too. Yeah. So let's write 1 kilometer is equal to the 100,000 centimeters. Now if we want this, so if we want to figure out what this is in kilometers, what we have to do is put what? This amount of centimeters on this side. And alright, that means that I have to go move the light again. Let me see. Alright, good. Yeah. Alright. So therefore, my box is on, well, not so much a box, is it? Alright, good. So now my box is on, my box is on the left. And if my box is on the left, I am going to let me see. Can I move that? There we go. There we go. Look at that. Okay. Alright, I think I solved my problem. I think so. Alright, I have an idea. Alright, cool. Alright, so yeah, so just to make your life nice, right? Draw a little line here, so whatever number you see up here, you just put it below. So yeah. Now, what is the beauty about dividing by powers of 10? You don't have to think about it. When you're dividing by powers of 10, you are jumping to the left. Just like this arrow is telling you. The arrow is moving to the left. Therefore, when you're dividing by powers of 10, you also jump to the left. So that's what I like about this, because it tells you. So even when you get to the metric part and you're dealing with powers of 10, you just jump back 1, 2, 3, 4, 5 times. It have 5 zeros. 1, 2, 3, 4, 5. So you're going to jump back that amount of times. Yeah? So therefore, you jump back 1, 2, 3, 4, 5 times. So therefore, the answer for this is going to be 3.75 kilometers. Yeah? Yeah. Now, what we've actually done here is literally just turn this into the 3.75 kilometers, right? That's what we actually did right here. Use words you can do that. So the map is always on the left, and the actual Or if you want to say real life, you can say that too, right? So map is always on the left, the actual distance is on the right. So when they want to know what the distance between 2 points is on the map, they will give you the actual distance. But when you need to find out what the actual distance is on the other side, they will give you what distance it is on the actual paper, right? So there are only two possibilities, right? So if they give you the actual distance, in other words, how far must your line be on a piece of paper? What is the length in centimeters you have to draw on your map for it to match this, right? So in this case, again, the box is on the left, right? Right? So the box is on the left, therefore we are dividing, yeah? So we're going to divide this by a 3.75. Now the question is, what is better to do? Work with this as a decimal or work with it as a fraction? Because I know that the 0.75 part of that is the same as 75 over 100, and if you break that down even further, you know that this is 25 times 3 over 25 times 4. Therefore, in its lowest terms, right, 0.75 would be 3 over 4. So what you really have, if you add 3 to this, you have 3 3/4. Right? So that's what you go have. So therefore your 3.75 is actually 3 3/4. Then of course 4 over 4 times that, 12 over 4 plus this, that's 15 over 4. Right? So the question is, if we divide 60 by this, then we must can divide 60 by the 15 over 4. Right? So sometimes it works out better when we have a fraction, right? Because if you look on it, I mean, if the 4 don't go into the 60, the 15 can go into the 60. So we don't know what will happen, right? So instead of we divide the 60 by the 3.75 and end up the foolishness, make we use this. So I could use the 15 over 4 and see what happens. So let me see how much space we have. So we have 60 divided by the 15 over 4. I'll just put that in. Yeah, put that in its own little border right there. Alright, so this become a multiply. This gets flipped upside down. So now the 15 over 4 becomes 4 over 15. So that means well, 15 plus 15, 30 plus 15, 45 plus 15. That means 15 times 4. So you divide this by 15, you divide this by 15. So 4 times 4. So our answer should be 16 centimeters. Yeah? Yeah. Yeah. So quite a few steps, right? So therefore, anytime you get a number like this, if so, and we have to be careful. Suppose them they do this. If we never get a number as big as say the 375,000, we would have to jump from here, and obviously our answer would have been something like, okay, 1, 2, 3, 4, and then you make one more. So instead of having 3.75, this would have been 0.0375. Yeah? Yeah. That's what would have to happen there. But that's not what did happen. So that's a hypothetical. Yeah. That's a hypothetical. So in other words, pay attention to the number on the right. Once it looks like this, whatever number you have to the right, jump 5 times to the left of that number. Yeah? Because no matter how you slice it, that is how you're going to convert this into kilometers. So whatever this number is, jump back 5 times. It will give you what you need to get in kilometers. And then, if they ask you for... Oh, sorry. They always do this to me. Always do this to me. Yeah, don't know why I'm always doing that. Alright, yeah. So, I like doing the trickier one, meaning when you have to divide, right? Because a lot of times, the multiply part is pretty easy to remember, yeah? If you have 1 or something and then you have 16 of them, you just take the 16 and multiply by that, right? So that's a possibility. So anyway, yeah. These are the, so those are the choices we have there. But me literally soon done. Sorry, me literally just a see this. So I just, but me literally soon done. But I jump it on again at 12 anyway. So I guess if you're on for that, then yeah, I can always come back and
yeah, that was quite a lot. So you know what? I'm not going to take up any more of your time. Thanks for helping me to stay consistent. And as I always tell you, honor your commitments. But let me play the last part of the previous one because it had something that I need to remember. So let's skip right somewhere about here.
yeah. So let me see. So 1, 2, 3, 4, 5, 6, 7. Really? Out of 7 I look so. 7, 8, 9. This should be 10. I suppose that's 11. And let's see what else. Alright. This one not so bad. 48, 80, and 112. Why not? So I put 12 over here, so even though that's kind of 48, 80, and 112. 48. See if that. Yeah, man, that's that this look like good practice now. No, no. Let's see. Let's just see how much of it everybody can see. Alright, yeah. Yeah, we'll go on this. We'll go on. So the beauty about doing these is that, again, once you're dealing with the adding and subtracting of fractions, once you can find the LCM easy, when you get the fractions to do and you need to find common denominators, is a breeze after you can go through this. Breeze. Because you get accustomed to finding the prime factors of every number. Right? You can look on 64 and know how much this is supposed to be. Right? You can look at 40 and know what's supposed to be in a that. Yeah? All the number them you can find anything you want about them. Right? Because you can look on this and say, alright, 72 plus 72, I will give you this number. Right? And you can say 72 times 3 will give you this number. So sometimes you can look at a smaller number and make out the bigger one then. This, I remember this from doing whole heap of questions about finding the radius and things like that. Yeah? So therefore, 77 plus 77 is 154. So therefore, you have 2 times 7 times 11. Yeah? So therefore, this have to be 2 times 7 times 11. Right? This look like when you add 56 plus 56. So therefore, you just multiply 2 by the 56, and 56 is already what? 8 by 7. So this is the same as like 16 times 7. Yeah? So when you can find the prime factors of every number, it just gets easy for do. So maybe that is something that I can explore on another time, just finding the prime factors of every number. Because I actually have a table for that. I have a table with like all, even when they teach me, used to make my student them write them off. Because sometimes it's good when you have them in your head. So like all this now, you said this is 2 by 5 by 5. This is 5 by 7. This is 5 by 13. Sometimes I just look on the numbers and I know what to expect. Yeah, so yeah, I'm gonna wrap up your sum. So find LCM and HCF of things like that. And when you can do this, anything else you get easy street. So we that now.